Hi, in today's lesson, I'm gonna explain the meaning of dispersion. So let's consider this illustrative example. So here we have a table that shows two sections, section A and section B. So two sections of 10 students, each in class X in certain school, were given a common test in statistics. So here the maximum marks is 14 and the scores of the students are given as follows. So let's get started by calculating the mean of the section A. X bar of section A is 6 plus 9 plus 11 plus till 35 divided by the number of the values, which is of the scores, which is 10. So here the result or the sum is 119 divided by 10. So here X bar of section A is 90. This is the first X bar of the section A. The mean of the section B has the same formula. So the sum of xi divided by n equals to 15 plus 16 plus 16 plus into 25 divided by 10 scores. So here X bar of section B is 119 divided by 10. So here the main of section B is 19 as well. So we have here the same mean of two sections, both section A and B. So here let's move to the measures of dispersion, and the first measure, which is the range. So the range, of course, here the scores of all the students in section A are ranged from section A, the scores are ranged from 6 to 35, and in the section B the scores are ranged from 15 to 25. The range is the largest number minus the smallest number. So here the range of the section A equals to 35 minus 6. So here we have 29. This is the range of the section A, and here the range of section B is equal to 25 minus 15 is 10. So here, even though we have the same mean of both sections A and B, and the mean is equal to 19, here the range is a difference. So the range A is greater than the range B, because 29 is greater to 10. Let's calculate the deviation of the scores from their mean. Let's get started with the section A, and let's find the sum of deviations from the mean for marks in section A. So here let's write down the scores. So we have here 6, 9, 11, 13, 15, 21, 23, 28, 29, and finally 35. As we know, the X bar of section A equals 19. So xi minus x bar, 6 minus 19 is minus 13, 9 minus 19 minus 10, minus 8, minus 6, minus 4, plus 2, 23 minus 19 plus 4 plus 9 plus 10 and finally plus 16. So if we try to sum the negative sign here, we find minus 41, and the positive signs here is plus 41. So here the sum equals 0. So there is the sum is 0, and the deviation of scores from the mean is neither large nor small. Is it a coincidence? Let's now find the sum of deviation from the mean for scores in section B. So we have here xi minus x bar. So we have 15, 16, 16, 17, 18, 19, 20, 21, 23, and finally 25. As we know, x bar of section B equals 19 as well. So xi minus x bar, so here 15 minus 19 is negative 4, negative 3, negative 3, negative 2, negative 1, 0, 1, 2, 4, and finally 6. The sum of negative signs here is minus 13. Here we have 0, and the sum of positive signs here is plus 13. So here the sum of deviation is 0 as well. Again, the sum is 0. Certainly it is not a coincidence. In fact, we have proved earlier that the sum of deviation taken from the mean is always 0 for any set of data. So we get sum of deviations to be 0. We cannot draw any conclusion from the sum of deviations. This problem can be avoided by following two methods. The first method is to take only the absolute value of the deviations to get rid of the negative sign of the deviations, and then take their sum. And another method is to square the deviation. So let's get started with the first method. Here the absolute value of xi minus x bar. So the absolute value of minus 13 is 13, 10, 8. In order to get rid of the negative signs, so here we take the absolute value of the xi minus x bar. So the absolute value of minus 6 is 6, minus 4 is 4. So here 2, 4, 9, 10, 16. Here the sum of the absolute value of xi minus x bar equals to 82. Another method is to square the deviation. So square the deviation of the scores from their mean. So here the minus 13 squared is 169, minus 10 squared is 100, minus 8 squared is 64, 36, 16, and so on and so forth. So here 4, 16, 81, 10 squared is 100, and 16 squared is 256. The sum of xi minus x bar squared is 842. So here let's calculate the second measures of dispersion, which is the mean deviation. The mean deviation of the section A equals to the sum of absolute value of xi minus x bar divided by the number of scores. So here the mean deviation of section A equals to 82 divided by 10, so equals to 8.2. The third measure of dispersion is the variance, and the variance is based to the second method, which is the variance is denoted by S square, because here we deal with samples and not with populations. So S squares is the sum of xi minus x bar squared divided by n minus 1, because here S is the sample. For that reason we divided by n minus 1. And here equals to 842 divided by 10 minus 1 minus 1, 842 divided by 9. So here the variance equals to 93.55. This is the variance, or the third measures of dispersion. Let's move to the fourth and final measures for dispersion, which is the standard deviation. The standard deviation is denoted by S, and S is equal to the square root of the variance, the positive result of the square root of the variance. So here the standard deviation equals to square root of 93.55. so here S is equal to 9.67. This is the standard deviation of section A. Let's move to the section B, and we follow the same steps. So here the first method to get rid of the negative signs is the absolute value of xi minus x bar, and the second method is to square the deviation of scores from their mean. So here the absolute value of minus 4 is 4, 3, 3, 2, 1. As we can see here, these negative values became positive values. So here 0, 1, 2, 4, 6, and the sum is 26. Here the 4 squared is 16, minus 3 squared is 9, minus 3 squared 9, minus 2 squared is 4, 1, 0, 1, 4, 16, and 6 squared is 36. Here the sum is 96. So here the second measure is the mean deviation of the section B, is the sum of the absolute value of xi minus x bar divided by n. So here the mean deviation of section B is 26 divided by 10 and equals to 2.6. The third measure of dispersion is the variance. The variance, as we noticed already, is based on the second method. So here the variance of section B is the sum of xi minus x bar squared divided by n minus 1 because here we deal with the samples and not with the population. So s squared equals to 96 divided by 10 minus 1, so 96 divided by 9. So here s squared, or the variance, is equal to 10.66. This is the third measures of dispersion. The fourth and the final measures of dispersion, which is the standard deviation of the section B, is the square root of the variance. So here standard deviation is the square root of the variance, the square root of 10.66. So here standard deviation of section B equals to 3.26. So let's sum up and try to find out the difference between section A and section B. Here the section A, the most measures of central tendency, of course, is the mean, the x bar of section A, and the most common measures of dispersion is the standard deviation of section A. So here section A, the mean of section A is 19, and the standard deviation of this section is 9.67. However, in section B, x bar of section B and the standard deviation of section B, even though we have the same mean as the section A, which is 19, however here the standard deviation of section B is less than the standard deviation of section A here. So the 3.68 is less than 9.67. We can conclude and say that we noticed here that the scores in section B cluster, of course, around the mean, while in section A the scores are spread away from the mean. This is for now. Thank you for watching. If you like the video, don't forget to subscribe to this channel. Thank you.